Design principle means I can start writing the code, class, module, function, okay, without thinking anything. So, uh, how I would land up in trouble in a sense that I can develop for few days, and after that slowly it will become kind of uh, blockers. Whatever we have done, it will not become the asset. Whatever we have done, it will become liability. So, designing is required. So, we'll talk about designing principle. What are the principles about the designing that we should take care? So, there is a designing principle generally. They come into picture called SOLID. So, first is single responsibility for S, and O is for open close principle, open for extensibility, and close for any modification. So, open close principle. So, we'll talk about open close principle. I believe it is one of the most important things that a developer or designer must know. Open close principle. So, what happens when we write a code? When we write a code, the best thing that a person should keep in its mind that code should be reusable. I'm sorry, code must be reusable. Whatever code, that's why the languages like C++ and Python, so these kind of languages evolved just for the code reusability. Whatever, even one piece of line code I write, then I should not repeat it. So it should be like I should be able to place at a place. I should be able to place it as a place so that I can reuse it. So reusing a piece of code what we are writing is the most aggressive thing that we see in any designing principle. So open close principle. If I'm writing a piece of code, if I'm writing a module, if I'm writing a class, or if I'm writing a function, so all are it's a kind of structures. Okay, so means all are data structure in the sense that they are unit of code that is better expression. So they are unit of code that can be scheduled. Okay, module can be scheduled, class can be scheduled, and function can. If I talk about language of Python, then these are runnable as a unit of code that can be scheduled to execute on the process. Okay. Now, if I am writing a runnable code, if I am writing a reuse, if I am writing a code that would get executed on the processor, then the code, either it is class, module, or a function, once it is finished, then it should be closed permanently for modification. It must not be a kind of modifiable in future in any way. So this is close principle, and it was given by one Mr. Meyer, and the his idea is that if a class is closed for modification and open for extensibility in the sense that if I write a class, then it cannot be modified. But if someone wants to extend in the sense he should be able to add methods to it, or he should be able to override a method on it, or if he wants to reuse a particular method. So three things we want from a class as per the extending it. We can add more functions to it. We can reuse a function. Okay, if function is already available, we should call it a reuse it, or we can override it. So three ways. So anyone who wants to, that is the reason someone wants to modify a class. If that is the case, then he should be able to derive from it and then extend it. Okay, or so this is his actually Mr. Myers theory. Or in Python world, I mean in object-oriented world, you can contain it also. So if you derive from a class, that is a kind of a black box now, because you know it what it does. So if you pass extrinsic parameter to the class, then you know how it works. So it leads like a flyweight design pattern among the design pattern, where you have a preset of its internal characteristics and preset of the interfaces that you provide from outside. So outsider interface, that is called extrinsic component, should be minimum, and internal component should be 90%. So whatever open close principle we are talking, that leads to flyweight design. So a piece of code, the unit of code what we have written, it should be closed in a way that whatever hint it takes from outside should be defined minimum, and whatever it does internally should be as max as possible. So this leads to a kind of reusable and active code. Okay, because it does something. Every focus is reusability. It's okay. A component can be reusable only when it does something. Okay, it does something on its own. If I ask a football player to play from this area, that's it. After that, he should fit into the situation on its own. So his internal component should be very high. Not that every time I am shouting from a loudspeaker, can you go left? Can you go right? Can you attack now? Can you stand? Just give the pass to that person. This is what we see, yeah, in the, and those teams generally they lose, because the power of the player is less, and externally we are pushing more. So this is not the open close. If a player is inside the ground, then he is close for any modification. Okay, now he should play on his own. This is expected from anything. Okay, so it is like a private design. But anyway, we are talking about open close principle. So when we are writing a kind of a class or function, and it is reusable, so one way is that it is inheritable. Other way is it should be contained. If it is contained somewhere, then the container can provide delegating functions to the external world. And whatever function they call, internally it will delegate this to the open close principle class object. So either we can contain it, or we can inherit from it. But there are gochas, okay, here. Like if we extend something through, if a class implements its own logic, okay, so if it a full-fledged class and implements own logic, implementation is solid there. Then extending from the implementation is like a, so if there is a class called A and it is full-fledged class, from A if I derive B, then I am dependent upon the implementation there. So it's a tight coupling. If there is a tight coupling, because implementation is already available there, then the class B will face problem when it has to be made of, it has to follow open close principle. So A is following open close principle. Then B has problem in following the open close principle if A is completely independent. But as per the Mr. Myers principle, open close principle leads to a solution, because if on this class, if 10,000 classes are dependent upon this class, then if I modify it, then all 10,000 are on stake. Okay, so in no way either I want to make it a artificial intelligence active component or a C++ object oriented reusable component in any way. It doesn't make any sense to change it once it is released to the market. We have to provide object-oriented fashion so that it should be extendable, in a sense that methods can be added, methods can be modified through overriding it, or it can be used. Okay, because Other dependent cannot afford changing. But later there is one Mr. Martin. So now he is saying that if the components what we have is what we have written and it has complete implementation of, then the component which derive from it, it is implementation hooked up. Means they are dependent with implementation. That is the case. Then, for making the derived class follow the open close principle, or anyone who is using it follow the uses can be either inheritable or contained. Then following open close principle for the guy who is using it is difficult. I mean, we can understand like this. I have a class called rectangle, and rectangle has width and height. Now it is open close principle. Now rectangle is closed. If you want, you can instantiate rectangle with width and height, and you can take back its width and height. There is a function called width, and there is a function called height. Now I have a now I want to calculate the area of the rectangle. Now I have a function called calculate area, and inside the calculate area, so in the function parameter, I take the rectangle as the parameter, and then rectangle width and height I take and calculate the area. So this function, calculate area function, certainly it is not following open close principle, because if I have circle now, I want to find area of a circle in addition to area of a rectangle, I need to change it. Now I have to take another parameter from rectangle and one as circle, and then I have to put if else. If rectangle is not none, then calculate the area like this. If circle is not none, then calculate the pi r square. So that is the area. If third is complete, so you keep changing calculate area. So this is implementation by the kind of a characteristics. So means we are bound because rectangle has provided implementation of width and height. There can be other way like there is a footballer. A footballer is a football player and he has a name and he has a role like he is a midfielder. So if I instantiate a football player is a class, then I have to pass the name and another, one string as name, another string as midfielder. Now there is a function called uh, get get uh, get filled. Okay, I mean demonstrate role. Demonstrate role is a function inside the footballer, whatever the class we use, footballer. Now footballer, okay, so demonstrate the role is a function. So or get the role. So if I call get the role, inside the get the role we have a switch state. If role is midfielder, then print a verbose message that he is a midfielder and what is his task. Okay. Now, like that, there are five things that is mentioned about the his position. Now, what about so that class is closed for any any modification. So a footballer has a name and his position or his role. Okay. Now there is a function called get role, and there if he is a midfielder, then nice printable statement is printed. If he is a goalkeeper, nice printable statement. Now I want one more rule as attacker. That is not there. So default is if it is not there by default, it will print this role. We don't know, but I want that role to. No, I have to modify that. I cannot. So I have to now, first of all, the get role should be virtual, and I have to derive from the footballer, and I have to provide get role, and then I have to provide one more switch statement that if this is among these switch statements that call the parent, otherwise call this. What about if I put 4 there again is required? So either I modify this or this is. So implementation wise relationship among the classes is not it is biased means it is not that clear. So Mr. Martin says that open close principle is good, but the relationship but the class which is closed for extendability, uh, which is closed for modification and open for which is closed for modification, open for extensibility, that should be in the interface. That should not be a concrete implemented class, because the class which inherited, they hooked up like a kind of they hooked up like in a more tight manner, that the other classes which either they contain it or inherit it, they become implementation dependent. If that is the case, they cannot follow open close principle. So what is the solution? So solution is interface based, but we would go with the Mr. Myers also. So when we write any open close following principle, even if it is a kind of, if it is an interface, pure interface, then we can extend another interface from it. That is another big thing, and then anyway we can realize it with the implemented class, or whatever functions we are calling in the open close based principal class, those functions should be polymorphic. That is the catch. If so, I mean, this is our philosophy. Okay, so we will probably kind of document it. So when we follow Mr. Myers principle, and then it is not required that it is interface only. So whatever the function we call inside the concrete class, those function must be I would say, must be abstract polymorphic interfaces, not the concrete function, the way we did in footballer. In footballer, we have get role, and there we play the full code. Okay, so rather than the role, what a footballer contains, that is a string, it will contain a polymorphic class. So role is a polymorphic class. Now, if someone wants a get role, so against that polymorphic class, so a footballer has a name and role. Name is a string, role is a string. Now, role is a polymorphic class. So against the role, if I say get role, that polymorphic class get role it will call. Now it is up to that class what it does. So this way we can keep adding as many classes as possible as a role, and that has anyway get role function through another polymorphic way. Whatever I want, cannot discuss those this much. So, and it is now extendable to any extent. So this is one way. Or we took example of rectangle. Rectangle has width and height. Now rectangle derives from a class called shape. That is an interface, and it has a pure virtual method area. Okay, so rectangle is a shape, and it implements area. Like that, circle implements area, parallelogram implements area. So if I have a calculate area as a function, it takes shape pointer as the argument, and whatever shape it will just call the area. Now it is extendable to any extent, and it is closed for modification and open for extensibility. So what we see here, that if we write any class that we want to follow open close principle, whatever function we call, functions must be through abstract classes polymorphic. This is what we say. Or if we cannot do that much, then it should be pure interface, like shape we introduced as pure interface. So that way, then we will make an interface open for so interface, that is anyway it is open, follow open close principle. We can extend another interface from the interface, or we can realize two solutions we provided. Either we make it as per Mr. Martin, make it as an interface, or this is our solution, that if you want to follow open close principle by a class, I mean any unit of code that would run on processor, either it is function, like function is also a class only in Python, or module, then whatever the function it is calling, whatever the subroutine it is calling, whatever the class method it is calling, all should be polymorphic rather than the concrete one. So this is our research. And then if you follow this, then our class becomes highly following open close. What is next? What is next? So next is Python. Python will come into the picture. Python decorator. Okay, so we said that as Mr. Meyer said, then we can extend, we can inherit from it, and then we can add method, we can override method, we can reuse method. Python has another way called decorator. If you place we place a decorator as a function, or if it is class, then I have to implement a special attribute call. So if I place decorators prior to any reusable component that follow open close principle, then decorator, they contain it and they provide, they use it. Okay, so all the functions, all the classes, we can happily write with open close principle in the Python. And if you want extensibility, please provide decorator. Decorator is meant for it, and it follows containment fundamentals. So please use open close principle in life.